Hi, welcome back to our Honors Geometry series. Today we're going to talk about 2.7. So this is our segment addition postulate proofs lesson. We want to start with some postulates other than the segment addition postulate that we need to know. Postulate 2.8 is our ruler postulate, and that states that the points on any line can be put into one-to-one correspondence with real numbers. Basically, that says that the real numbers can all fit on the number line, but we already knew that, and we really don't use it a whole lot, to be honest with you. Postulate 2.9, the segment addition postulate, that's the one that is the main focus for today's lesson. So if A and B and C are all collinear, then B is between A is between A and C if and only if AB plus BC equals AC. Not necessarily a midpoint, but it can be. In class, we use some flashcards to sort of reorganize a two-column proof. We're going to skip that for right now. So some more vocabulary that you need to know. A point is a midpoint if it bisects a segment or cuts it into two equal parts. And to be congruent, the definition of congruence is that two figures are congruent if and only if they have the same measure, if they're equal. Now, you're going to use the definition of congruence a lot, so I would get that one written down. I would have that one memorized. If you need to pause the video at any point to write down notes, you can always do that. So let's do a proof. 6 steps of a two-column proof are shown. Copy and complete the proof. We're just going to give the reasons on this first one. So my suggestion for you, and I would write these steps down when you're proving something. Whenever you're writing a proof, you want to start with the given statements. Then you do any definitions. Look for some vocabulary words that you can define. And then after that, at least in this lesson, you want to look for your segment addition postulate. That's the big focus of today's lesson. Okay, so those are the first 3 steps. After that, if you get stuck, you can always look back at step 2 or your givens to see if there are any substitutions that you can make that you haven't made yet. So those are just some general first steps that you can use. So we start with the givens. Then ST is congruent to ST is congruent to TU. Well, how do we know that ST is congruent to TU? Well, we had our givens. Now we should look for some words we can define. And the midpoint of a segment, we can define that. If T is the midpoint, then what do I know about those two parts? Well, if T is the midpoint, if it bisects the segment, then 7x and 3x plus 20, or ST and TU, must be congruent. And that's what step 2 says. It says they're congruent, and we were able to say that by the definition of the midpoint. Because we knew what the word midpoint was, we were able to say, well, if T is a midpoint, then ST is congruent to TU by the definition of midpoint. Now, step 3, again, I said earlier, the definition of congruence comes in pretty much every proof today. Step 3, how did I go from congruence to equality? Well, I have no numbers really that I can use in this proof, at least on the left side. But what do I know about congruence? If they're congruent, then what can I say about the measures? If they're congruent, then they must be equal. So by the definition of congruence, I can say that those two are equal. And then on step 4, I had ST as a segment, but then I substituted in 7x for ST. And I had TU as a segment, but then I substituted in 3x plus 20. So you can see that instead of TU, I put 3x plus 20. Instead of ST, I put 7x, but they mean the same thing. All I did was substitute in my known values. And from here, you could probably finish this proof. I would encourage you to pause the video and try to finish this proof on your own, and then unpause and check your work. You should have 4x equals 20 by subtraction property of equality. Subtraction property of equality. And then your last one, x equals 5, by the division property of equality. And if you need to, again, pause the video to write any of this down, you are obviously always free to do that. Let's try another 2-column proof. So you write down your givens. SU is congruent to LR, TU is congruent to LN, and I want to prove that these two things, ST and NR, I want to prove that those are congruent. So how am I going to do that? Well, I start by writing out my given statements. And then I put down what do I know by the definition of congruence. So what does it mean for SU and LR to be congruent? It means that they're equal. What does it mean for TU to be congruent to LN? It means that they are equal. So I did my givens, I did my definitions. And my third step, if you wrote this down earlier, you would remember it. You can also rewind quite a bit to the beginning of the video. That at least in this lesson, our main focus is on the segment addition postulate. So on the segment addition postulate, make that a better S. Segment addition postulate. And what can I say by the segment addition postulate? Well, the segment addition postulate, if you remember, says that one part plus another part equals the whole segment. So one part plus another part equals the whole segment. So you need to know that ST plus TU equals SU. And LN plus NR equals LR. Okay, so there's that. I'm going to change colors now. And what I really want, I want to prove that ST is the same as NR. I don't have any numbers. I don't have anything that I can really do algebra with right now. So if you check the next step on our algorithm, I want to go back and use anything that I haven't used yet from my above steps. So I've already used both of these. I said by the definition of congruence, they're equal. But I haven't used these facts yet. So what I would want to do is I want to look to substitute in some known values for something else. So instead of SU and TU, what could I put in there? Instead of SU, I could put LR. I can substitute in LR because they're equal. Instead of TU, I can put LN. So I can now say ST plus LN equals LR, and that was my top equation. Then I could say LN plus NR equals LR. And what I did there was I just substituted my known values. I substituted LR for SU because they're equal, and I substituted TU for LN. And now what do I have? I've got two things that both equal LR. So think of this as like A equals C and B equals C. Well, if A equals C and B equals C, how are A and B related if they're both equal to the same thing? If they're both equal to the same thing, then they must be equal. Both of these pieces are both equal to LR. So what I can do is I can substitute in ST plus LN equals LN plus NR. I ran out of room. I was able to substitute this stuff for LR, or, this stuff here for LR, or you could think of it as substituting this in for LR here. And now, what was I hoping to get? Let me check back in. I want to prove that ST and NR are equal. I want to prove that these two things are equal. Can I simplify this equation? Is there anything that I could take away from both sides? Well, I could always take away ln from both sides to get st equals nr if I subtracted off ln from both sides by my subtraction property of equality. And my hint for you is, it looks like I'm close. It looks like I might be done. But this says congruent. This says equal. So they're not the same. Congruence and equality are not the same. And I want you to look back at steps 1 and 2. I started with they are congruent, therefore they are equal, by the definition of congruence. It also works the other way. I could say, well, if they're equal, then they must be congruent, by the same definition of congruence. All right, we got 2 more proofs to do. I would encourage you to take a look with me at A through D, and then I'll give you a chance to finish the proof on your own. So here, given JL is congruent to KM, prove JK is congruent to LM. Prove that this little part is congruent to that little part. And they started off with the givens, then they did their definition of congruence, which is good. Then they did the segment addition postulate, just like we're used to. But now, here's kind of a strange step. Typically, I would have put in between B and C, or between C and D, I would have put that JK plus KL equals KM and KL plus LM equals KM. That way you can see a little bit more clearly that these two things are both equal to KM. So you can set those equal to each other like we did earlier. But they didn't do that. Here they combined a few things into one step. And they have that JK plus KL equals JL. KL plus LM equals KM. And they said, well, these two things are equal. So I can just skip a step here and put these two things equal to each other. Because one equals JL, one equals KM. But JL and KM are equal to each other, so it really doesn't matter. I'll just skip a step and say that those two things are equal. Typically, I would like you to put a step somewhere in here, substituting JL for KM, because they're equal, but they didn't do that. So now you have JK plus KL equals KL plus LM by the substitution property. And I would encourage you to pause the video and try the last proof on your own, or the last bit of the proof on your own. See if you can get that, and then unpause the video and check your work. So E should have been, you notice they just threw in this minus KL on both sides. Should have been subtraction. Property of equality. And then you should get JK plus, ooh, actually no, that's not right. JK equals LM, because these cancel or reduce to 0, and these reduce to 0. We're left with JK equals LM. And you could say simplify, or you could say combine like terms. And then JK is congruent to LM by the definition of congruence. Okay, last one. Given WX is congruent to YZ, prove that WY is congruent to XZ. I would try to get as far as you can without watching the video. When you get stuck, unpause the video, and then I can help you through the rest of the proof. So I start with my givens. And again, if you haven't paused the video, I would do that first. WX is congruent to YZ. That's given. My definition of congruent. So if they're congruent, what do I know? If they're congruent, they are definitely equal. So WX equals YZ. Please disregard the lowercase y. I am just incapable of drawing a uppercase Y right now. And 3 I gave you was the segment addition postulate. But what segments do I really want? Look back at your prove statement. What did they want me to prove? They wanted me to prove something about WY here. So let's do that one. How can I use segment addition postulate for WY? WX plus XY equals WY. And again, that should be an uppercase Y. Just pretend it is for me. They also wanted me to prove something about XZ, so I should probably do that one as well. So XY plus YZ equals XZ. And from there, again, I would encourage you to look back at what we haven't used yet. We haven't used our substitution that WX and YZ are equal. So where do I see a WX or YZ that I could substitute for? Well, there's one. So let's make that a YZ. So YZ plus XY equals WY. And then you have XY plus YZ equals XZ. Take a minute and I would pause the video and look at these two things. What do you notice about these two expressions? How are they related? And you'll notice that even though they are a little bit out of order, they are the same thing. They're equivalent. So there I substituted. Now, what you could do is you could say, well, YZ plus XY equals WY. If you want to get really technical, YZ plus XY equals XZ by the commutative property. But at least in our class, for right now, that is optional. What really matters... Oh, that's not what I wanted. Is that you notice those are the same. So if those two things are the same, then these two things must also be the same. So wy equals xz, again by substitution, and then 6, wy is congruent to xz by our definition of congruence. So let me know what questions you have. Send me an email with your homework questions, and I will see you soon.